Welcome to AGWA, the Automated Geospatial Watershed Assessment Tool video series. AGWA was developed by the University of Arizona with the USDA, ARS, Southwest Watershed Research Center, and the US EPA. AGWA is available at www.tucson.ars.ag.gov/AGWA. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is the 13th video in this series, Prepare Data for AGWA. This is video 13A, Prepare the DEM Soils and Land Cover Data. Video 13B will demonstrate how to prepare the precipitation data to run the SWAP model in AGWA, and video 6 showed how to prepare the precipitation data for Kinneros 2. Video 12A demonstrated how to download the data required for AGWA. The DEM data used to determine watershed boundaries, topography, and slope were downloaded as a USGS 10-meter DEM. Obtaining the 30-meter data is a similar process. LiDAR data, however, can be delivered in different formats, so we won't cover them in this series. The soils data include a polygon layer with an associated database of soil properties available as NRCS STATSCO or SERGO data, or as the FAO soil map of the world if your watershed is outside of the United States. The land cover data show the distribution of landscape classes across a study area and are used by AGWA to determine land cover type, interception, Manning's N roughness, the percent impervious surface, and curve numbers. These data are available as NLCD or GAP data or from custom data sets. There are two main steps when preparing data for AGWA. The first is to project all data to a common coordinate system. ArcMap can project on the fly for visualization or map production, but AGWA requires the data to all be projected to the same coordinate system so the models run properly. For example, the data used in these videos for the mountain fire example were all in the UTM projection Zone 11 and the NAD 83 datum. The second step is to clip all data to the area of interest. This reduces the amount of time for processing, especially if your area is large, and also reduces the amount of computer storage required. Your data will likely be in different coordinate systems. For example, the DEM data from the national map are in the geographic coordinate system with the NAD 83 datum. STATSCO and SERGO data are usually in the World Geodetic System with the WGS 84 datum, while the NLCD land cover data are in Albers conical equal area projection and the NAD 83 datum. ArcMap can project these data using the Project tool under Data Management, then Projections and Transformations. Remember that there is a different tool for feature classes than for raster data like DEMs. AGWA requires all units to be in meters. For example, the mountain fire tutorial data are in UTM Zone 11 North, NAD 83 datum. After your data are projected, you'll clip everything to the area of interest or the watershed boundary. Remember that smaller data extents will have faster processing times, so you'll want to select the smallest extent for use for clipping. You can use a watershed outline or HUC watersheds, as in this example at Fort Bliss, Texas, or an area of interest, such as the boundary of Fort Bliss. Or you can use a watershed that intersects an area of interest, such as this watershed that intersects the fire perimeter of the mountain fire. It's a good idea to buffer your watershed to at least 1 kilometer or 1,000 meters to be sure to include the entire extent of your area of interest. Then use this buffered watershed to clip the data. Note that there are different clip tools for features and rasters. For soils data, you can use the NRCS Surgo or Statsco datasets. The soils data that are downloaded include a geodatabase and two subfolders: a spatial folder that contains the GIS polygon layer, and a tabular folder that includes the associated soil attribute tables. The tables are imported into the geodatabase using Microsoft Access. The import is done after the clip, so only the data for the soil types in the analysis area are imported. To import the tabular data, double-click on the soildb_us_2003.mdb database to open it in Access. When the screen opens, click on Stop All Macros, then click on Enable Content at the top of the screen. In the Surgo import screen that opens, paste the full path to the tabular folder into the form, then click OK to import the tabular data into the database. The Soil Report screen appears when the import is complete. Click Exit to close Access. The soils data are now ready to use in AGWA. The next video, 13B, will demonstrate how to prepare the precipitation data for use in the SWAP model in AGWA.